Welcome, everyone! Today we're diving into the fascinating world of solar heating systems. As a steam fitter or pipe fitter, understanding the piping layout and basic equipment installation for these systems is becoming increasingly important. Let's start with the basics of solar energy. The sun provides an incredible amount of energy, more in 1 hour than the entire world needs in a year. This energy reaches us as radiation, primarily visible light and infrared heat. As you can see in this diagram, about 47% is visible light and 46% is infrared, which is the thermal energy we actually use for heating. While solar energy has been used for heating water since the 1890s, its effectiveness depends heavily on location and season. For instance, Alberta gets about 80% as much solar energy annually as Florida. But here's the catch. During an Alberta winter, the available solar energy drops to just 25% of what you get on a summer day. This seasonal imbalance makes solar energy scarce exactly when we need it most for space heating. Now, let's look at how we capture this energy, starting with passive solar heating. Passive systems don't rely on mechanical equipment like pumps. Instead, they use the building's orientation, design, and landscaping. Notice how this house is set up. Evergreens and an earth berm block the cold north winds, while deciduous trees on the south provide shade in summer, but let the sun shine through in winter when they lose their leaves. A more sophisticated passive approach is a direct gain system. Here, large south-facing windows let the winter sun in, striking a heavy thermal mass, like a concrete block wall or water tanks built into the structure. This mass absorbs heat during the day and slowly releases it at night to moderate the room temperature. The roof overhang prevents the higher summer sun from overheating the space. Moving on to active solar energy systems, these use mechanical equipment like pumps, heat exchangers, and flat plate collectors to capture and move heat. This diagram shows an active air system. The collector heats the air, which a fan pushes into a large rock storage bed. When the house needs heat, another fan blows air over the warm rocks. Air systems won't cause water damage if they leak, but they do require bulky ductwork and large storage areas. Alternatively, we have liquid active systems, which are much more compact. In this two-fluid system, a mixture of water and antifreeze circulates through the solar collector, where it's heated. It then passes through a heat exchanger to warm a separate liquid storage tank. From there, the hot liquid is pumped to a heat coil in the ductwork to warm the house. The main drawback here is the potential for leaks or freezing if the antifreeze mixture isn't maintained. Because we need domestic hot water year-round, active solar systems for this purpose are often more economically practical than space heating systems. This diagram shows how it works. The solar loop preheats city water in an auxiliary tank. This preheated water then feeds into a conventional backup hot water heater. By preheating the water, the solar system can supply a significant portion, sometimes up to 66%, of a family's annual hot water needs. Finally, let's look at a heat of fusion system. This uses a concentrated saline solution in the collector that turns solid below 32 degrees Celsius or 90 degrees Fahrenheit. When it heats up and melts back into a liquid, it absorbs a massive amount of latent heat. This latent heat is then transferred to the storage mass. The big advantage here is that you can use a much smaller solar panel to achieve the same total heat capacity. To wrap up, understanding solar heating systems is crucial for modern pipe fitters. Remember the difference between passive systems, which rely on design, and active systems, which use pumps and fluids. Whether you're working with bulky air systems, compact liquid systems, or innovative heat of fusion setups, knowing these basic installation procedures and operations will serve you well in the field.